Hi everyone, good morning. I hope you are able to hear me. Can anyone please confirm?
Yes, Basu, we can hear you.
Okay, I'm just going to create the cluster first. Just give the name of the cluster and hit on create compute. So we know already how we can do set up all these things. And meanwhile, I wanted to talk few things. Just give me 1 minute. Yeah, I hope you're able to hear me. So why we need to go for Databricks? We're already having a data factory. We're already having a data factory. Data factory also is going to help you to do the data ingestion. You can do, and you can do the data transformation. So then why we need to go for Databricks that we're going to see. So before this data factory and before Databricks, we were having Hadoop. Before Hadoop, we have a traditional ETL tools. Traditional ETL tools like SSIS, Informatica, or DataStace. So like that, there are some traditional ETL tools. So these tools are not capable enough. Because of that reason, we are moving out of these tools because this is having a limited number of connectors. Limited connectors will be there. At the same time, it supports only structured data processing, and this will support only for batch processing. No parallelism. Okay. So there are many limitations. The cost wise is also is little more. Cost is also more. Okay. So these are all the limitations with the traditional ETL tools. Okay, so because of that reason, since it is taking longer time, since these systems are not capable enough to process the data, because of that reason, we moved from traditional ETL tools towards to the Hadoop. Okay, so Hadoop was introduced very long ago to process the big data. So this is not going to support for not for big data, not for big data. But when you go for Hadoop, you can do the big data processing. Okay, so here also we have a limited connectors, but still for data ingestion, you may use the scope. There may be other tools, not sure. Okay, so but basically when the people are working with the Hadoop, there is a component called scope. Okay, so it's a part of the Hadoop ecosystem. And the scope will be used for data ingestion. And it supports a big data, and it handles all varieties of the data like structured, semi-structured, and unstructured. And this is also going to support only batch processing. If you need a streaming, then you need to go for other components. Okay, and here no cluster. And here we are going to have a cluster. And distributed files, distributed storage. Distributed storage and distributed processing. Okay, so here no distributed. No distributed. So no distributed means no distributed storage and no distributed processing. So now these differences will say why we need to come out of this traditional ETL tools towards to the Hadoop. Okay, so we are not here to learn about this Hadoop. So we need to know why we need to come out of from traditional ETL tools to Hadoop. Okay, so when the Hadoop was introduced, there was no Spark, there was no Databricks, there was no ADF. Okay, so that time this Hadoop made many changes in the data processing side. So if you're having a varieties of the data, then these traditional systems are not suitable to process the data. Because of that reason, we used to go with the Hadoop, and it supports for commodity hardware, and we can set up the cluster with less price. With less price, we can set up the cluster, and here you need to have a on-prem cluster only. On-prem ENV. Okay, so these are all the options, these are all the benefits that we're having. So cluster means I talked about when I talked about the ADLS Gen 2, I mean to say the data is going to be distributed across the different nodes. We are going to have a cluster. So data is not going to sit in one place. Data is going to be distributed across the different nodes. But here it is a single system. All the data has to sit in a monolithic system. But here it is a distributed system. You can have a connectivity. So that is what it is, a cluster. Collection of systems is nothing but a cluster. But here there is only one system. A single system is going to be used to process the data. You may have a multiple cores. That's not going to help. That's not going to help much more. But when it comes to here, the nodes itself is going to be different. So multiple systems are going to be connected together. So in order to maintain this entire cluster, we have a resource manager. Okay, so resource manager is something like an operating system. Okay, so to maintain all these resources, we need resource manager. We have a resource manager if you go for Hadoop, or we have a Mesos, Kubernetes. Okay, when you go for Hadoop, you can use any of the resource manager to manage your resources. And who is going to set up all these things is going to be different. Okay, so you have to set up everything. You means the administrators will be there. Hadoop administrators are responsible to set up the cluster, to set up the environment, to process the data. So then only we can do it. If any of the cluster is down, and it is going to be taken care by your administrators. We are not going to worry about it. So I'm just talking about briefly about the Hadoop. How this process is going to be happen in the cluster is basically this Hadoop is having three components. Hadoop is going to have three components. One is HDFS, and second is MapReduce, and third is resource manager. These three components will be there in the Hadoop. HDFS for storage. MapReduce is for processing, and resource manager to manage resources. I hope you are with me, right? Is everyone clear what I'm trying to talk?
Yes, boss.
Okay. So here I'm just giving some brief idea about the Hadoop to say why we need to go out of the Hadoop. We are not with the Hadoop now. Most of the projects, 70 to 80% projects are moving towards to the Spark. Okay. So here we have three components in the main of Hadoop. And Hadoop ecosystems, there are many Hadoop ecosystems, Scoop, Hive, Pig, HBase. There are many systems are available on top of it. Because this Hadoop is going to use this MapReduce. Okay, so I'll tell you again why we need to go for towards to the Spark. But when you compare this to Hadoop is changed many things in the data processing side. Okay, so revolution happened to come out of all the traditional tools towards to the Hadoop. Okay, so prior 5 years, even this Hadoop was little good. Okay, so now the Hadoop is not in a good position. Very, very bad position. And one more thing is Hadoop will be there. Do not think the Hadoop completely removed uh, because of the Spark. Hadoop was removed only one component. Hadoop is having three components here. Hadoop is having three components. Out of these three components, only this part only is removed. This part is replaced with the Spark. Your HDFS remains same, your RM remains same, and only the MapReduce was replaced with the Spark. Okay, so because of that reason, people are looking towards to the Spark. Okay, so distributed storage, we talked about it at the time of ADLS Gen 2, and distributed processing, we'll talk about it. And your Hadoop is a distributed processing system and distributed storage. Okay, Hadoop distributed file system and resource manager and MapReduce. Now we need to know about why we need to come out of your Hadoop to Spark. So these are all the advantages I have given here. So let me give the limitations of the Hadoop to come out of the Hadoop. So to come out of the Hadoop, I wanted to give a limitations. So limitations is it's hard to write the code. Hard to write a code. Okay, because too many lines of the code you have to write it. And you need to write the code in the form of Java. Most of the ETL developers adopting this Java is not easy. It's very difficult. Even I was tried, I was not able to do it. I went for getting up to skill up in the Hadoop, but it's really, I feel it is very difficult and it is not even possible for me. Okay, so that much difficult it is. A normal ETL developers like me cannot get update with the Java. So that is one limitation. And apart from that, even if you adopted the Java, you have to write hundreds of lines of the code for small task also. So I'll take one difference. Okay, so we'll say if I wanted to do some word count, how many lines of the code that you're going to do it in a Hadoop. The same thing if you do with the Spark, how exactly it is going to be there, you can feel. When the Spark was introduced after some years, I started getting update again towards to the big data technologies. So before that, even Data Factory was not much good in the market. And one more thing is Data Factory is not built for data transformation. Okay, so Spark was good. Okay, so later I started getting update this. I feel the Spark is very, very easy. because we don't need to write too many lines of the code, and we don't need to sit for only one language. When you go for Spark, what happens is, along with the Java, you can have a multiple languages. Like you can write a Java code, you can write a Scala code, you can write a Python, and you can write a R. So these many languages are supposed by your Spark. So if you're not interested to write a Java, then you can go for this, right? So the reason why people are much more interested is because of the Scala and Python. The Spark was designed with the Scala. The Scala language, it was designed. Scala was designed with the Java. Okay, so forget about all those things. We have a feasibilities to write the Scala, and we can also write a Python code. Python, when you write a Python with the Spark, then we can say it is a PySpark. Okay, so
Doubt, sir.
yeah, please.
The Spark means it is a tool, sir, or
Spark is a framework,
framework.
data processing framework.
Okay, sir.
It's not a tool. Okay.
Yeah,
It is a framework,
yeah, I can say engine, a Spark engine.
of course. Data processing framework or data processing engine. Okay. So we can write the Python code, we can write the Scala code, we can write the R also. Okay, so when you write Spark plus Python equals to PySpark. Okay, you got my point, right? This is one of the best advantages. It's a general purpose. You can use any language here. That much flexibility we are going to have it. But when you go for Hadoop, it was fixed with the Java. Okay, so that is one limitation. Another limitation is more disk IOs. Okay, so here very less disk IOs. Very less disk IOs. Okay, so that means what does it mean? Let's say, for example, so I'm having HDFS. So this is the underlying data store, right? For your Hadoop, this is the underlying data store. Even for this also, I'm going to use the HDFS only. You can use HDFS or you can use ADLS. You can use S3 bucket, GCP. And here I'm using a HDFS. Just imagine, you can take only HDFS also for reference. And I have with Hadoop, we are going to write HDFS is one component for storage, another component is MapReduce. Okay, so let's say, for example, I have a map1, map2, map3, and map4. Just imagine, 4 maps are there. So what this is going to do is map1 means it is a transformation 1, transformation 2, transformation 3, and transformation 4. So I have some data here in the HDFS. So just imagine emp.csv. Some file is there, some data is there. I wanted to process this data. So to process this data, what you have to do is first you have to read the data. So your reading means multiple IOs. Okay, so one time you're reading from the HDFS, and then you're applying some transformation. And once you apply the transformation, again you're going to load the data into HDFS. So one time reading and one time you're reading and writing. Okay, so there is a one more transformation, second transformation. This entire thing is a one job. This entire part is one job. Okay, so this map, map reduce 2 or mapper 2 is going to again read the data from the HDFS. So which data is going to read? The output of this map 1 is going to store in the HDFS, and you're going to read again, sorry, this direction. It is going to read the data again from here, and once it is done, the output is going to store inside this same HDFS. So mapper 2 output will be taken by again map 3. So M3. And again, it is going to do some transformation. Output will come, that output will be stored here. And the output, whatever the output is stored by this M3 will be taken by again M4. The final output you are going to store here. This is a final output. Okay, so this is the input. But how many times you are reading here? 1, 2, 3, and 4. 4 times you are reading it. 4 times you are reading, and 4 times you are writing. Writing also 4 times, right? So total 8 times. So here we have a multiple writings and multiple readings and multiple writings. So this is one of the problem, one of the major problem. So this kind of process they used to call it as a disk-based processing. Disk-based processing. Because it has to go to the storage and again you are reading it. Every time you are doing some transformation, loading the data here, and again it is getting read from here. You don't need to say what is the file name or something. Okay, so that will be taken care by your Hadoop framework itself. You don't need to worry. You're just going to give the input and output details, but internal mechanism will be taken care by your Hadoop MapReduce itself. Okay, so this kind of process we used to call it as a disk-based processing. So Hadoop supports disk-based processing. But if you take the same thing here, I'm just going to say M1, M2, M3, and M4. Same thing only. Instead of MapReduce, we are going to use the Spark. So what happens here is, you're going to read only one time. You're reading the file, same emp.csv. And this is the transformation 1, transformation 2, transformation 3, transformation 4. And you're applying a transformation 1 and getting the output, right? That output you're directly giving it to the transformation 2. You're not coming back to the storage again. You're just giving it. And you're applying some transformation here. Again, you're giving the output of this mapper 2 to the mapper 3. And output of this mapper 3 will be given to mapper 4. And output of mapper 4 is going to give it to the HDFS. How many times you're reading? Only one time. And writing is one time. So this entire process is going to be happen, right? This process is going to be happened in the RAM. In-memory processing system. Your Spark is a in-memory processing engine. The processing is going to be happened in the RAM. So when you go for Spark, you need to have a more RAM. GBs of RAM is required. But here it is not required. Because you are doing the disk-based process. So later this RAM was very cheaper. Okay, so that point of time, your Hadoop was introduced or your traditional systems were introduced. The RAM was costly. Now the RAM is a bit cheaper, right? So they started investigating why don't we do the processing in the RAM itself, so that we can give a second with one person to another person. So map 1 is person 1, person 2, person 3, person 4. We are giving the output to their hand to directly. So the performance will be faster. So since the processing is going to be happened in the RAM, the processing will be faster. As per this Spark documentation, they're saying 10 to 100 times is faster. 10 to 100 times faster than Hadoop. Just imagine how fast it is. You got my point, right? This is one reason is more enough to say why we need to go for Spark. Okay, clear? Any doubt here? Okay, so cluster will be same, like Hadoop cluster only will be there here also. Okay, so here this Spark, I can call it as a Apache Spark. Okay, so some team they designed a framework to process the data within the RAM. Within the RAM, they wanted to process it. So they designed this framework, and this framework named it as a Spark. The Spark was donated to Apache, and then they named it as a Apache Spark. So Apache Spark is a open source. Apache Spark is a open source. Everyone can take this Apache Spark. Okay, so these things I'm just going to give at higher level. More languages will be there, and it is very faster to compare. It is very faster to process the data when you compare with the Hadoop, and it is also going to handle all varieties of the data. Everything is same. Only the processing was replaced. Your Hadoop processing with MapReduce, this MapReduce was replaced with the Spark. So when you write the code with the Spark, the lines of the code is uncomparable with the Hadoop. Okay, so I'll show you the difference. I'll take one of the use case. The word count, you need to write too many lines of the code. Even you cannot understand that. I'm sure until unless you are a Java developer. If you ask me, I cannot understand. But if you do the same logic in the Spark with just 4 to 5 lines, you can do it. 4 to 5 lines only. Even you don't even feel that is very difficult, even if I write it in a single line. So that much simple it is. Very, very simple. Okay, so now I understand, right, why we need to go out of your Hadoop to Spark. Now Spark is a open source. Apache Spark is a open source. Now let me talk about a few things about the Apache Spark. So Apache Spark is an open source. And this will not, no client support, no customer support. No customer support means, for example, I wanted to sell one product. I designed one product. I'm selling the product to the different customers. So different customers, they're taking a product from me. So when I say no customer support means, can you buy a product from them in general? No. 100% is. Because if you take a AC, if they're not supporting client support, then you cannot take it. If you take a laptop, you'll be having customer support. If some problem comes, who will solve your problem? In the same way, here we are not having any customer support because it is an open source. Apache Spark is a foundation. They don't do any support for the software. They don't do any support. Okay, so they donated the Spark to the Apache, so named it as Apache Spark. So no customer support. The people who designed the Spark, they are very intelligent. Because of that reason, they gave what they wanted to give. So they made something in hidden. Some features are hidden. And those features, they made it as a commercial. I'll talk about it. So no customer support, then definitely we are not going to use it, but no license, no cost, no no license cost, because it is an open source. You can take it. So some companies, okay, especially smaller companies, are much more interested to go with the Apache Spark. If they face any issue, they have to solve the problem by themselves. They cannot go and ask Apache Spark, can you give me a solution for my problem? If I face any problem with the ADF, I can raise a request to the Microsoft and Microsoft customer care, and they will come and help us to set up, or they will come and help us to solve the issue. They may take the price. They will take a charge for their support. But here, no customer support, no price, nothing. You have to solve your problems. So working with the Apache Spark is very difficult. Okay, very difficult. And one more thing is, this Apache Spark is not having a, what I can say, like IDs are not available. Integrated development environments are not available. The third is no IDs. Like if you go here, if you wanted to use this Apache Spark, they have to go for Visual Code. So this is the third party tools. PyCharm or Jupyter notebooks. So some other things will be there. So those IDs you need to use to do or to work with the Apache Spark. Because Apache Spark is having only interactive command. It is having interactive command only, but no IDs are available. So that is fine. You can go with other tools. Okay, so like PyCharm or Jupyter, you are going to pay some cost to them because IDs are required. If you don't have IDs, then you cannot work with the Apache Spark. Okay, and no security, no data security. Because this is a framework, this will give a process only. Okay, so they will not provide the security for your data. So since it is a processing engine. Now, where your data storing? HDFS. Okay, so to provide the security, again, you have to use the HBase or Hive, something like that. You have to go for providing it. Okay, and one more thing is no storage. No storage and no resource manager. There are many nodes are available. Only it is going to do the processing very faster. That is the best feature. The reason why people are going towards to that. Any resource manager is already there with the Hadoop cluster, and Hadoop cluster is having the storage. And the way your Hadoop is providing the security, I mean to say HBase or Metastore, they're going to create it on top of it. Hive. In Hive, they're going to provide the security levels will be there, but not at that higher level. Even if you go, I'm not sure about the Hadoop ecosystems. So you can just explore how they used to provide the security if you wanted. But in general, I'm saying, since they're not providing any storage here, there is no point of talking about security with the Apache Spark. Okay, so these are all the limitations. Now, the people who designed this Spark, they started a company called Databricks. They started a company called Databricks. And their product also is same. Product name also is same. They started a company called Databricks, and their product name also is a Databricks. Why they started this product? They already found this Spark. Then why they went for this is they started marketing. It is not a open source. Okay, so Databricks is extension of your Spark. Databricks is a extended version of Spark. You got my point, right? These people are much more aware of it, what limitations that we are keeping, and they wanted to make this as a commercial. This Databricks is not a free. Databricks is a commercial version, but Apache Spark is a free version. Any company can take it. Okay, any company can take this Apache Spark. Microsoft also has taken. And AWS also has taken. And Databricks also has taken. Of course, their own product it is. Okay, so on top of this Apache Spark, they created a product called Databricks, and their company name also is a Databricks. So extended version of your Spark is a Databricks. Now extended version of your Spark in Microsoft is Dataflow. And extended version of your Spark in this place is Glue. I'm not sure about the GCP. GCP also, I think Dataflow they have. I'm not sure. Okay, so they started providing a product. Why? Microsoft also know if I can provide a support to the customer, then people will take a product from me also. And AWS also thought the same thing. If I provide a customer support for Spark, then people can take at least my customers, or at least few of my customers will take a product. And Databricks, much more before all these people, Databricks was there. Okay, so Databricks was started very earlier before of this. Okay, so this was succeeded like anything. The market was adopted with the Databricks. Okay, so now Microsoft is also trying to provide. They have a Fabric. Okay, so Fabric is there with their own product, and of course this Databricks associated with the different people. So here, just ignore all those things. Just concentrate on this area. So Databricks, if Databricks is not an open source, then you need to pay the license. There are many companies there that they don't have any problem. They wanted to go with the Databricks because they have a budget. They don't want to take the risk. They don't want to spend a lot of time to investigate the issues. They don't want to take the lot of time to set up the cluster. So here you have to set up the cluster. Need to set up cluster. Takes more time to set up the cluster. Here, user interface is there. User interface are there, and collaboration is there. The word collaboration can be done here. Here also can be done, but you have to use the other tools. With Apache Spark is not going to be possible because they don't have any collaboration. And cluster management is easy. Cluster management is easy. So that means if I wanted to increase the cluster size, you can increase whenever you want. If you want to decrease the cluster, you can decrease the cluster. Here, when you go with this one, 24/7, your cluster should be in running mode. The Hadoop cluster is going to be run 24/7 because your storage and cluster tightly coupled. But when it comes to the Databricks, the storage and cluster are isolated. The Hadoop, the cost is very huge, more cost when compared with the Databricks, because your cluster is tightly coupled with the storage. If cluster is not running, then you cannot access the storage. But here, the Databricks, your cluster is isolated with the storage. Your cluster is isolated with the storage. Because of that reason, the cost is less. So storage cost is very less. Okay, even if you go with this one, storage cost is very less. But processing cost, your cluster cost is very huge. Okay, but here, since they are tightly coupled, your I mean to say your compute should run 24/7. But here it is not like that. The cost is less. Okay, we don't need to set up the cluster from our side. Everything will be taken care by Databricks itself. Okay, so many features, performance by default they have taken care internally. And security, leaf level security also is possible now. Previously it was not there. Once the Unity catalog was introduced, at the leaf level security also we can provide. Okay, any question? Why we need to go to the Databricks? When you're working with the Databricks means what? You're working with the Spark only. Okay, so on top of the Apache Spark, extended version of your Apache Spark is a Databricks. In the same way, Dataflow also they tried, but it was failed. Because they tried much more UI, and this is not 100% UI. For UI, for many things UI is there. For transformation, you need to write a coding only. It's a 100% coding. But it is very easy to work with the Databricks. Is anyone there working with the Databricks? Having environment with the Databricks?
Yes, sir.
Okay, pushless, right?
Yes, sir.
Okay. So you will be having the navigations, all those things. The rich navigation will be there if you go with the Azure Databricks. If it is a community edition, the some features are not available. And if you go with the Azure Databricks premium, because you're paying license, right? So you will be having more features. But this is how the journey was happened from traditional ETL tools to Hadoop to Spark, and Spark to, I mean to say Apache Spark to Databricks. Okay. So working with the Apache Spark is little difficult. The only thing is like you need to use the HDFS commands, you need to know about it. Okay, so to deal with the file system, here we have HDFS commands. In Databricks, we are going to have a commands called a DBFS commands. Databricks file system commands. Okay. So we are going to see how we are going to deal with the DBFS file system. And I wanted to give one more thing. Okay. So it's a generic talk only. These things are much more enough why we need to go for Databricks or from Apache Spark to Databricks, and from Hadoop to Apache Spark, and from traditional tools to Hadoop, why the people moved, that I explained about it. In the same way here also. So how to explain few differences. That's more enough. Okay. And one more beauty thing when you come for this is within the same place, within the single notebook, you can write varieties of the languages. Like you can write a Python in the Databricks. You can write a SQL, and you can write a Scala, and you can write a R. All the languages you can write within the single notebook. But I'm not sure about Apache Spark, how exactly it is going to be. Is that possible to write multiple languages within the single file? Not sure, because I did not work with the Apache Spark. So I work with the Databricks only. Okay. So if you get this kind of requirement, just try to think. If you're not having any offer, then you can take an offer. Working one time is fine, but it is little difficult to submit the job, to make sure the cluster is up and running. All those things I feel little difficult. But when it comes to the Databricks, it's much more easier with just one click away. If the cluster is not available, you just hit on the start, it is going to be started. So that is what we're having here. Okay, so you can stop the cluster, you can start the cluster. And like if you go for Databricks, if your cluster is idle for 20 minutes, it is going to be automatically stopped. Automatically, cluster will be stopped. And if you wanted to reduce the time, you can reduce, or if you want to increase the time, you can increase. We have two different types of clusters. Again, to reduce the cost, when it comes to here, we have two different types of clusters. One is all-purpose cluster and job purpose cluster. All-purpose cluster and job purpose clusters are going to be there. So when we can use this all-purpose cluster is at the time of development. You're going to use all-purpose cluster. So 24/7, are we going to do the development? We are not going to do. Okay, but when you go for Hadoop cluster, it has to be there 100%, 24/7. Because even if you don't use the cluster, you have to read the data from the storages. To read the data from the storages, definitely you required a cluster. Okay, otherwise, because the storage is coupled, they're tightly coupled. But when it comes to here, Databricks, your data storage is isolated. Okay, so Databricks is not going to connect it with your HDFS directly. Your HDFS is going to be there somewhere. And one more thing is ADLS also. There is no relationship between your ADLS and your Databricks. Databricks is separate company, ADLS is separate company. And the same way, Databricks is separate company, S3 bucket is a separate company. In the same way for GCP also. Okay, so they designed the Databricks. One more thing I wanted to say, Databricks. What they did is, these people are not having the cluster. They have a feasibility to do the cluster management, but they don't have own clusters. They don't have own resources. Systems are required, right? Okay, so Databricks is a framework. Okay, this framework is going to take care about cluster management. All the things is going to be taken care, but they don't have a cluster. They have a software, they don't have a cluster. So missions are not available. So because of that reason, what they did is they associated with the cloud providers. They don't have their own cloud. Maybe in the future they may get it, not sure. But now they don't have. So they associated with the Azure. And they associated with the AWS. They associated with the GCP. So since they associated with this, they're calling that Azure Databricks. Okay, so you can work with the Databricks. Same to same, there will be no change. And they also associated with the AWS. We are calling it as a AWS Databricks. Okay, so year ago or a couple of years ago, this Databricks is also associated with the GCP. So GCP Databricks. So since it is associated with the AWS, from Azure, we are going to learn with the Azure Databricks, right? We are going to learn Azure Databricks. So what is coming from the Azure Databricks and what is coming from the Databricks? From Azure, storage will be there, data storage, and compute will be there. These two will be there. Only these two they will give. How this compute is getting managed, your Databricks will take care. How this storage is getting used, that will be taken care. Okay, reading data from here, writing data into this place. Only it is a framework. This framework will take care about the storage. This framework will take care about the compute also. The same way, the way Azure is providing, in the same way AWS also is the same way. AWS, when it is having with the AWS, they will use the S3 bucket, and when it is there with the GCP, and GCP file system will be used for storage. Okay, so compute will be provided. Now, your Databricks is associated with the Azure. So whatever the revenue is getting by Azure, we are paying the license to Azure only. We are not giving the price to Databricks. We are giving a price to Microsoft. So some share will go to the Databricks company. Let's say, for example, if you pay 100 rupees, out of 100, some percentage, let's say 50-50 for understanding, 50 rupees with the Azure and 50 rupees will go to the Databricks. If you take hypothetically 50%. Okay. Now, Microsoft internally, they thought, why I need to pay 50% to Databricks? Why I need to depend on them? They will get a thought, right? Not only that, not only for them, even if we are there in that position, we also get the same thing. We are paying 50% is because we are dependent on them. The same way Databricks also may think they will definitely go for their own cloud. Definitely they will set up, but it may take some time. Okay, so that is one thing. Because of that reason, what Microsoft has done is, this Databricks was done with the Apache Spark. Now, what Microsoft has done, they also taken this open source and they created a data flow with the ADF. Previously, ADF is not having a data flow. Okay, so before data flow, if any project was there before data flow, they used to do the data transformations with the stored procedures. Okay, with the stored procedure, but they have a Azure data warehouse. So on top of Azure data warehouse, they used to do the data processing. It's a different story. Forget about it. So later they provided this data flow. It's 100% way. 100% way. We already come across this data flow, right? We already seen. If you remember, data flow debug we used. What the data flow debug is doing? Data flow debug is going to start the Spark cluster. So Spark cluster is required here. Okay, so in all these places also we are going to have a Spark cluster. Here also we are going to have a Spark cluster. Here also we are going to have a Spark cluster. And here also Spark cluster will be there. The same way here also. Who is going to start? Your data flow debug is going to start. But it is failed. I feel it is failed. Failed piece it is. Now, these people, I mean to say, this Microsoft knows why we need to depend on this Databricks. And again, they have taken the same and data factory also, and storage, compute, all those together, they named it as Azure Synapse. I hope you're following with me, right? There is one more product, they brought it. This product is having ADF. This product is having ADLS. This product is having Synapse notebooks. Like your Databricks. And this product is having Azure Data Warehouse, ADWH. So they brought all together into one umbrella. Into one umbrella, they brought it and they named it as a Azure Synapse Workspace. This is also almost failed. Why it is failed is because huge cost. People are not interested to go with the Synapse notebooks because the cluster price is very huge. Okay, so because of that reason, again, what Microsoft is doing is, bear with me, I'm just taking different ways. Because the cluster is going to be like too much cost and it's taking longer time, and it's not much more flexible for the users. So because of that reason, Microsoft Fabric came into picture. So this is also going to have all together. Same notebooks will be there. PDF will be there. PDLS also will be there. We used to call it as a lakehouse. Data warehouse will be there. Power BI is there. What not all the things are there. Data sciences related stuff is there. Machine learning related stuff is there. So they brought this entire thing as a SaaS service. Software as a service. But this is a platform as a service. Okay, so because of the cost, people are not much more interested to have this Azure Synapse. So because of that reason, Microsoft brought this Microsoft Fabric. Okay, so previously we used to write a certification called DP 203. Since they are concentrating, since they are more branding on the Microsoft Fabric, they have taken out this DP 203. They come up with the DP 700 for data engineers. Okay. Now, if this is going to be succeed, but still there are some issues are there. I'm sure they're going to solve it. And this product is going to beat the Databricks also in the future. Down the line, like 3 to 5 years, you can see drastical changes in the data processing side. Okay. Any question as of now?
In Fabric, only the cluster will be used.
All
Azure.
clusters will be up and running. Okay, so you will be having a pool. You can directly take it and run it. Once that is done, then it will be given back to the Microsoft itself. You don't need to start the cluster. Here, if you go with the Databricks, you have to start the cluster. You have to start the cluster here. But here, you don't need to do that. Will be taken care.
Okay.
Cluster is already started in
Yes.
Microsoft Fabric.
Yes, started clusters will be there.
Mhm.
You don't need to wait till your cluster is started.
Not closed, not terminated.
Yes, not terminated, not closed. Many features they brought.
But in the Fabric, we have data engineering also, no?
Of course, that is what I'm saying, right? We are having all the data engineering
Yeah.
related stuff only. Now, if you are going
Yeah.
to work with the Fabric, then we are going to be treated as a Fabric data engineers. This term is going to get into the market in 2 years, much more.
After 2 years, again we have to learn Fabric.
You have to work, you have to learn, because Microsoft no need to pay 50%, right? You got my point? Here they're sharing 50% share if they're using Azure Databricks. If they're using an entire Microsoft Fabric, 100 rupees with them only. If they have 100 rupees, what they can do is they will give for 80 rupees to the customer. 20% discount, 30% discount, because their own product.
So present Azure Databricks is there, sir, or it is?
No, it is there, man. You cannot get immediately
Okay.
because trust is not there still, because internal Microsoft projects are if Microsoft is tempting other persons with less price, or if there is any brand new projects, they may go with the Microsoft Fabric. But this is proven. Databricks is already proven. So people will never go immediately, right? It takes some time. I'm just saying feature. Okay, at this point of time, not even 5% projects are existed with the Fabric. If you take 100% projects here, it's uncomparable, right? It takes very longer time. 3 to 5 years will take. If there is any brand new projects, then there is a chances to have it.
After 2 years, when Microsoft Fabric will popular, then on that time Azure Data Factory and Databricks
Azure
will be
Data Factory also, I'm sure, 3 to 5 years, mark my words, you may not have Data Factory alone. That will be there with the Fabric only.
that means data ingestion we will do in
With the
Microsoft.
Data Factory, within the Fabric only. So Fabric is an umbrella. Under that you have a Data Factory. Data Factory is there here also, with the name called Data Pipeline. The naming standard is Data Pipeline. So if you work with the Data Factory, Databricks, you don't feel much difficulties to work with the Fabric. So initially you may feel some little difficult, but not much difficulties.
And the only one of the reason is people are having different kind of subscriptions for every services they are taking. Now it will come under one
Yes,
subscription.
yes. You don't need to set up the environment, right? Even you don't need to
Yeah.
create a cluster.
That means Microsoft Fabric is very easy compared to ADF and Databricks.
Yes. But still there will be some issues. Even I got some people who are working already with Fabric. They're saying sometimes some issues are getting with the notebooks when they're writing a code. Okay, so because they're much more habituated with the Azure Databricks, and they're facing some issues, but still issues will be there. But surely I'm sure 100% this product is going to be succeeded project. And we don't need to write many times the code. We don't need to write many things that we can generate it. They made it much more simpler. Okay.
Also for the reporting, it is very easy.
Yes.
They are making.
Yes.
Then from JSON to till visualization, all this happen.
Everything will be there in one place. One lake is there. Okay, so connectivities are easy, and many connectors they provided. When you go with the Databricks, you don't have a much more connectors, very less connectors. But when you go for Microsoft Fabric, they're giving hundreds of connectors. Okay.
But currently there are a lot of limitations going with Fabric.
Of course, limitation, because this is just kid only, right? So definitely there will be many issues.
When we talked about Power BI over there in the Fabric, we checked that there are a lot of limitations, like you can't create calculated columns, calculation groups.
Calculation groups or calculated
Calculated column, calculation groups, nothing is
calculated
available.
columns you can create, right? With the modeling, you can have it.
When we checked it, calculation groups were not there.
Okay.
And if the size exits their memory as per your license, then
you have to increase it.
they move the data from import to direct query.
Okay, that is also problem.
Yeah.
So they wanted to make you to buy capacity.
even if we buy. Because one lake, they say you don't need to store the data, keep it in Power BI. It's
Yes.
always going to fetch it from the storage, one lake
Yes.
storage.
Yes.
Then I don't understand why it exists, the memory size
Okay.
and those
So
things.
even in this one, I did not work with Microsoft Fabric, but I got updated on it. In one of my project is going to be used this one, but I was not the part of that particular project. I was with the Databricks.
So
Even now in my current project, I'm with the Databricks. Instead, they have taken for this one, and it is taking time to get into the stage to work. So because of that reason, they moved me to the Azure Databricks project. Okay, so if you can work with this one, working with the Databricks is not much difficult. You can feel easy to work. Okay. Any questions? I'm stopping here. And tomorrow I'm going to talk about, still I did not talk about the Spark cluster, how Spark cluster is going to work. Okay, so at this point of time, I don't want to talk at the time of audit. I'm going to talk about the Spark cluster. And tomorrow I'm going to start talking about a DBFS commands, a Databricks file system. If you want to deal with the Databricks file system, how you can deal with that, I'm going to talk about it. Okay, once that is completed, we'll talk about the Spark cluster, what is the driver node, and what is the worker node. So definitely there will be an interview question. So that I'm going to take you through that. And if you work with Apache Spark, memory management also is important. But when it comes to the Databricks or Fabric, it will be taken care by internals. You don't need to worry about it. In my entire experience, I work with the Databricks. I never work with the Apache Spark. So I didn't even think about how this memory management will be done. So that will be taken care by Databricks itself. So you strongly say that I work with the Databricks. And do not try for working with Apache Spark, because later some point of time you have to move towards to this. Okay, so many limitations. I mean to say, working point of view, it will be difficult. If you are interested, you can, if you have a Hadoop experience, then you may not feel much difficulties. But if you don't have a Hadoop experience, then definitely you feel difficulties. I recommend you say that I work with the database. Okay, then I'm stopping. We'll see on tomorrow to talk about DBFS commands.
And RDD, will you leave it? Yeah, you will teach us.
I'll teach that. RDD also I'll teach it. Okay, it will not take much time. I'll teach that.
Mhm.
Okay. Thank you for joining.
thank you.